Okay, today let's talk about the code 3320 problem. First part is the description. It is the rock paper scissors game. More specifically, there is a difference between this problem and that classical game. That means there are three kinds of card: E, F, and W. So the F can win E, W can win F, and E can win W. Alice and Bob are playing this game. You are given Alice's strategy to play the card. That means you are given a string, includes consists of these three letter E F W W E F. That means this is the string S. That means Alice will play the card based on this string. You need to help Bob to make a strategy of playing card that can help Bob to win the game. Win the game means the point that rewarded to Bob is strictly greater than Alice. This is the problem. There is also another limitation that means Bob cannot play the same card on the continuously two round. That means Bob shouldn't every time Bob play the E card, he cannot play E again after the last E. But E, F, E, this is acceptable, actually. So the problem is require us to return the number of situations that Bob can play the card that can help him to win the game. Finally, okay, this is the description of this problem. Next part, let's talk about the solution. In solution part, we need to talk about the limitation of number or value in this problem that can help us to make a valid solution. Actually, the star length is smaller than 1000. This indicates that if we make a strategy that can the time complexity is less than square of n, this can help us to make the solution valid in limited consuming time. I mean, square of n is 1 million. It is also acceptable for this problem because it can run in several seconds. So, after know this, we know one problem is one solution for this is every time we check every letter in string, we can preserve an array. The key of array is the score we can obtain in current round. That means score. The range of key will be minus s star length, and the maximum number of the score will be s dot length. This is the key. What about the value? The value will be the numbers of situation. That means we can preserve the array when we check every round from 1 to the last round. When we check the every round, we need to update the array one round by one round. So the common type fallacy will be below square of n. How to update the array? That means it is not a hard problem. More specifically, if we can list all situation for the last round, we can play the cards we can play. I mean, there are 3 kinds of situation: E, F, and W. For the current round, we also have 3 situation E, F round. For the limitation that we cannot play the same card in the continuous 2 round, so when we play E in the last round, we cannot play E right now. So the situation will be E2F, E2W, F2E, F2W, W2E, W2F. This will be the situation. We can list all situation to update the array. Maybe this is array last, and this will be array current. We can make it if, and that means for this update, what we can do is WCUR W current plus equal last WCUR plus equal E last, and FCUR plus equal E last. This is what we can do to update this situation. That means the F current, the numbers of situation last round is F, and the current round will plus equal the number of situations that E is last round. That last round cards will be the E. So in this situation, we can update it. We can give another example, F2E and F2W. So that means E current plus equal F last, and the W current plus equal F last. This is how to update the F. So this is how to update the array. Maybe we can change the format of the array, more detail in the code. But this is the core idea about this problem. Okay. Next part, let's talk about the complexity. First part is time complexity. Actually, we need several loops. Time complexity will be first we need there are n rounds game. So the first complexity is n multiply. The second will be the array, the length of the array. That means this length. So the length of the array is 2n. So multiply 2n. Second, in addition, for every round we need to update 6 situation for every last letter. We have 2 situation to in the next round. So there will be 6 situation to update. So we need to multiply 6. This is the time complexity about the solution. That can be O. This is time complexity. We also can make it O square of n. This is time complexity. And next is space complexity. For the huge array, we need to save several keys. For example, first is around multiply the length of the array. The last one will be previous last the letter we played in the last round. I mean 3 multiply 3 last and current. Actually, we don't need the last round because we need its current round. So, this will be this is the space complexity. But when we update the next round, what we only need is current round situation. We don't need the first, second, third round situation. So we don't need so much space complexity. If you want to make more optimization for the space complexity, you can reduce this to 2 because you can use it when you update one round. What you only need is the last round situation, so the last round array. So you can reduce it from n to 2. So the best space complexity for me will be this. That means 2 multiply 2 multiply 3, 12 or 12. That will be O12n. This is the best space complexity for this problem. Okay, you also can make it O. So this is the answer, time complexity and space complexity. This is all about this problem. Thanks for your watching.